Hi guys, I know it's been a little while, but let's get back into some of these videos. Today we're going to have a look at the nomenclature of organic compounds. We have started to do this in class, but it's time we sort of formalize this process, and it's very complex. We're going to revisit this concept a number of times, and it's probably important for us to start the process of getting a bit of an idea about how this works. So the important thing about organic compounds is that organic compounds are compounds that are based on carbon. So most of the ones that we're going to look at initially are going to be the hydrocarbons. So they're ones with hydrogen and carbon in the structures, but we will also be looking at a few later on with oxygen and possibly even nitrogen in there. Carbon, hydrogen, and oxygen forms a very important group of organics called the carbohydrates, and fats are also compounds that consist of carbon, hydrogen, and oxygen. And when we throw nitrogen in there, we get amino acids, which are the key components of proteins. But most of the ones that we're going to be looking at in this little section are going to focus on compounds of hydrogen and carbon, mostly with a little bit of oxygen. We organize organic compounds on the basis of the similarities between the different members of a group. So there's certain types of what we call functional groups, and these functional groups are the ones that code for the specific types of characteristics of a group. Now, the first thing we need to do is we need to look at the number of carbons that are present in our organic compound. The naming of the number of carbons can be found at the prefix to the name. Meth has 1 carbon, so an example of that would be methane, which is a compound we've looked at before. Eth has 2, prop has 3, bute 4, pent has 5, hex has 6, hept 7, and oct is 8. You're only pretty much expected to go up to 8, but I guess to complete the sequence, non is 9, and dec, as you probably would guess, is 10. So therefore, something like decane would look very similar to methane with the same functional group, the same ending, but methane has 1 carbon and decane has 10. There's a few important functional groups, and we will visit these through both the preliminary and the HSC courses, but for the moment, these are the ones that are the most important. The alkanes are the ones with a single bond. So a single bond between the carbons, and then we fill everything else up with hydrogens. So the simplest of these is methane, which is 1 carbon. So this one here would be ethane, and all of these little spots, which I won't fill completely in, would be filled with hydrogens. Where there is a double bond present, then we have an alkene. Notice that that "ene" ending is the end, and the alk bit is just like the family group. So we substitute the alk for meth for 1, eth for 2, prop for 3, and so on. So the alkenes are characterized by a double bond. Notice that we can't have methene. This cannot exist because there can be no double bond. Carbon has to bond with at least 1 other carbon in order for us to have a double bond. This is also the case for triple bonds. We can have triple bonds as well. So the first compound that we know of, the carbon compound with a triple bond, would be this one. It has 2 carbons, so it is eth, and then the triple bond is characterized by the Y-N-E ending. So this would be ethyne. 2 other groups that are worth mentioning at this point, but not worrying too much about them, are the alkanols or the alcohols. So the most common of those is this one. Okay, this is 2 carbons, so it would be ethanol. And again, hydrogens are all the way around this particular molecule. But the OH group on the end there is an indication that this is an alcohol or an alkanol, and it would be named ethanol. And the last group that we'll quickly mention is the alkanoic acids. Some important ones here are ethanoic acid or acetic acid. They have a COOH group, and then the rest of the molecule is just filled with hydrogens. So this would be ethanoic acid. And from the video we looked at earlier today, it would form an ethanoate salt. When we're building the alkanes, we can do this with Lewis diagrams, which we'll talk about in another video, but also with the molecular modeling kits. You can see that we have methane here with a central carbon. So I might just change the color here. So a central carbon atom and surrounded by 4 hydrogen atoms. So in this particular case, you can see that each of these bonds has been created by having 2 electrons being shared. This one actually looks like there are 4, but there should only be 2 here, 2 here, 2 here, and 2 here. To create an hydrocarbon from the same group, from the alkane group, with a second carbon, you'll notice that we slot the carbon in here where the hydrogen used to be, and we add the 1, 2, 3 more hydrogens on in place of where that 1 hydrogen was before. So each of these groups grows by the addition of a CH2. And that helps us to identify patterns in the formula. And you'll see there's actually a particular way we can express the formula for alkanes. And that is, if the number of carbons is n, then the number of hydrogens is 2n plus 2. So if carbon is 1, n is 1, 2n plus 2 would be 2 times 1 is 2, plus 2 is 4. So the first one is C1H4, which we know is methane. So here are the first 4 alkanes. You can see methane is here with the single carbon and then the 4 hydrogens around it. In the second one, we have 2 carbons. This is ethane and 6 hydrogens around those 2. The next one is propane with 3 and butane with 4. So we have 4. So we have each of these building on as the formula CH4, C2H6, C3H8, C4H10. So you can see each time we're adding 1 carbon and 2 hydrogens to our molecular formula. And this is the way, this is a trend that we can find for the alkanes. The alkenes are a little bit different. The alkenes have this double bond here, so that's why we can't have methane, because there's no double bond. We don't have double bonds between carbons and hydrogens. We have to have at least 2 carbons in order to have an alkene. So the formula for ethene would be C2H4. Underneath is propene. Formula for propene is C3H6 and so on. Butene would be C4H8 and so on. So the formula for these particular compounds, you can see simplified down here. CnH2n. So when n is 2, 2 times 2 is 4. Now don't forget that the naming is something that is also interesting about each of these. And when we looked at butene, we said there was a problem with butene because we could have the double bond on the end carbon, or we could have the double bond on the central carbon. The formulas for each of these are still the same. And the problem is that when we have ambiguity equals numbers. So whilst the formula for both of these 2 compounds here is C4H8, the position of the double bond changes. We need to number the carbons from the smallest number. This is going to be small no matter which end we look at it from. And we always take the smallest number that we possibly can to indicate the position of the carbon. So you can see the smallest number in the first one is 1, and for the second one it's 2. So the first one would be called but-1-ene, and the second one would be but-2-ene. And this is how we distinguish between these two different compounds. So given all of that, can you name the compounds below? Well, the last slide was a bit of a clue for this one. So the first one has a double bond between the 1, 2 carbons. There are 3, 4 altogether. We have a double bond. So because we have 4 carbons, it's a but. Because we have a double bond, it's an ene. But because there's ambiguity here, right here, we need to indicate the number. And the smallest number here is 1. If we number from the other end, it's 1, 2, 3, 4, and these are much bigger numbers than 1. So the correct name for this compound here is actually but-1-ene. Similarly, the second one here has the double bond between the second and third carbons, so it will be but-2-ene. This one has a chain in which the double bond, the longest chain includes the double bond, is only 3 carbons. And there's actually a little side chain here coming off. That's a little trickier, and you'll have to ask me for the answer to that tomorrow. Thanks for watching.